Unit 1. Sampling and Sampling Distributions. 1.1 Sampling Theory. Dear students, in this session, we will discuss about the evolution and the need for sampling. Statistics is a branch of mathematics that focuses on issues that cannot be solved using mathematical theories and concepts. Statistics can be classified into theoretical statistics and applied statistics. Theoretical statistics emphasizes on studying the theories, concepts, principles, and formulas. For instance, the concept of measures of central tendency, such as mean and mode. Moreover, it's study about what kind of formula can be used to calculate mean, mode, and median. Whereas applied statistics emphasizes on how to apply statistical theories, rules, and formulas to solve various real-world problems incurred at individual, organizational, and national, as well as international contexts. For instance, theoretical statistics intends to find the formula used to calculate mean, whereas applied statistics helps to make economic, social, and technological, as well as health-related decisions using mean, mode, or median. Therefore, various researches are conducted using applied statistics. Applied statistics is categorized into descriptive statistics and inferential statistics. Descriptive statistics involves various measures used to summarize a data collected from a given population or sample, such as parameter and statistic. Parameter means a measure obtained from a population, such as population mean, population median, population standard deviation, etc. Statistic means measure obtained from a sample, such as sample mean, sample median, sample standard deviation, and sample proportion, etc. Whereas inferential statistics focuses on making conclusion or generalization about a given population based on the sample collected from the population. This concept is associated with inductive reasoning. There are several reasons to make conclusion about a population based on sample result. Those deriving factors increase the need to study about sampling theory. Hence, we will discuss about the concept of sampling, the need for using sample, and the various techniques of sampling. First of all, let us see the key statistical terminologies associated with sampling. What is the difference between population and sample? The term population means all members that meet a set of specifications or a specified criterion. For example, the population of Ethiopia is defined as all people residing in Ethiopia. The population of Dire Dawa means all people living within the city's limits or boundary. A single member of any given population is referred to as an element. Element is the basic unit of a population. Population is the totality of elements about which decision is made or the totality of elements being studied. Example: a population of persons, televisions, bees, documents, etc. Sample is collection of some elements or subset of the whole population. It is a group formed from two or more elements of a population. It is a subset of a population. What is the difference between census and sampling? Census is about complete enumeration, gathering information from all elements of the population. Sampling refers to the process, techniques, and methods of taking sample from the whole population. When only some elements are selected from a population, we refer to that as a sampling. When all elements are included, we call it a census. 1.2 The need for samples. As we discusses in the earlier session, most of inferences or conclusions made about a given population are made based on sample data. Collecting data from sample will be essential in the following situations. 1. Adequacy of sample results. When the information collected from sample as well as from the whole population is expected to bring the same result, it is better to collect data from sample. This is because it helps to collect the required data at low cost and short time. If the population is homogeneous in nature, taking random sample from the population is very effective. 2. When contacting all population elements becomes time-consuming. That is, if the population size N is very large by nature, it will be mandatory to select some representative elements from the whole population instead of considering all study objects or all elements of the population, whether it is finite or infinite. If the population size is very large, it is difficult or impossible to gather data from all population elements. Moreover, when excessive data is collected, it may result in generating vast amount of data challenging to analyze and summarize properly to generate meaningful information. 3. when cost of studying all items in the population is often high. Example: collecting information from 100,000 people demands more human resource, materials, and finance than collecting information from 10,000 people. 4. The physical impossibility of checking all items in the population. Example: the population of fish, birds, mosquitoes, and the like are large and are constantly moving, being born and dying. So, checking all would be difficult. 5. The destructive, exhaustive nature of certain tests. If all food products of a company, X Abraham Food Complex products, are tested for quality, there would be no product remaining for sale. Blood test, urine test, and hospital are also good examples. So, to ensure that the product meets minimum standard, a small sample is selected. 6. Nature of the population enforces to take sample. Example: if a quality control expert in a given manufacturing factory wants to take sample to check whether the process is in control, he takes certain amount of samples at some periodic intervals from the goods in process for inspection, due to the fact that inspecting all goods is impossible. 7. Infinite nature of the population. When a research is needed to study infinite population, it will be compulsory to select some representative sample from the whole population.